And my point is, science really gives us an opportunity to get information about our environment. In the case that I'm discussing, it allows us to ask, is there a smarter kid on the block? We live in a certain neighborhood. It would be worthwhile finding out, right? And obviously, I mean, if you don't put funds in this direction, if you don't fund it at a level, for example, of LIGO, where $1.1 billion were invested in trying to detect gravitational waves, or, you know, if you don't fund it at a level of the search for dark matter, which is comparable to this, then how do you expect to find anything? You know, it's sort of like stepping on the grass and saying, look, it doesn't grow. If you don't fund it, you won't find it. People often say extraordinary claims require extraordinary evidence. My point is, first of all, it's not an extraordinary claim that we could find technological relics of other civilizations, because we know that you know, half of the sun-like stars have a planet like the Earth, roughly at the same separation. So there are billions of Earth-Sun systems in the Milky Way galaxy alone. And if you arrange for similar circumstances, you might get similar outcomes. Why should we be special? So I would actually say that it's a conservative, you know, assumption to make that is common sense, that we are not special. But okay, well, even if you accept the idea that it's extraordinary, my point is extraordinary conservatism leads to extraordinary ignorance.
Yeah, I like that. And you know, I grew up in a Greek Orthodox culture. I love my culture. It's one of those things where you know, the religion is tied in with the culture. And growing up, I had a lot of questions with the faith, and I find myself still questioning today. But it was not a popular thing to ask questions, and it's a, you know, it really is an orthodoxy of thought, and so really what you're pointing at here is that science as an, or academic science as an industry, is like a battleship that is a huge ship. It's a huge organization, and to get that organization to turn in very quickly on a new idea that challenges everything that we've thought before, that is the cultural, like human. That is the human effect of people doing science. That's just because we're humans. If we were robots, we wouldn't have that,
so
right?
That's one complaint that I have, but I have actually a more serious concern, and that is, you might say, okay, people are conservative, they're slow to move, like you're saying, it's a giant ship, slow to move. But there is another issue, which is that a substantial fraction of the mainstream right now in theoretical physics is working on ideas that were never tested against experiments in the past several decades and will not be in the next several decades, like string theory, extra dimensions, the multiverse.
Well, and they're called theories, which is the most, from me, as I've talked about this in the podcast before, they're not actual scientific theories. They're like theories of like just a general word. It's actually a hypothesis, right?
Yeah, but there is no problem with hypothesis as long as you can put skin in the game, that you make predictions based on that theory and test them against experimental data. Now, in the context of these theories, you know, there are hundreds of people working on them, but there is no prediction that can be tested. They don't put skin in the game. And you ask yourself, how can that be mainstream? Well, there is a very simple reason for that. Because if you have this sandbox where you can demonstrate intellectual virtuosity, you know, mathematical gymnastics, where you show that you are smart, and you don't make predictions so that you cannot be proven wrong. It's all mathematics. That's the ideal setup for, you know, not putting skin in the game and getting high reputation, because you claim that you're doing physics, but you can never be proven wrong. And great, so then you maintain your high reputation. You cannot ever make a mistake that will be shown by an experiment to be the, you know, you're going in the wrong direction. Now, I find that unfortunate, because we are supposed to describe nature, and, you know, it's just like a shoemaker that decides to bake cakes at some point, you know. So physicists that decide to be mathematicians, you know, it's legitimate, but don't call yourself a physicist, because a physicist is about trying to describe reality and putting skin in the game, just like kids, you know, they get bruised, literally speaking, they put skin in the game.
Mhm.
And in the context of astrophysics, we do that because there is a lot of experimental data and we test theories. And it's all about, if you propose an idea, it's all about the idea standing up to the scrutiny of evidence. And
Right.
so what I find disturbing is that when I am guided by evidence that looks anomalous, I could be ridiculed.
Mhm.
Whereas at the same time, people that talk about extra dimensions that we've never had any clue for
Right.
are regarded safe, and they can talk about it in the
In career
mainstream, give each
paths.
other awards, and
Right.
everything is fine. So I think
Mm.
something is unhealthy in the current culture. I think people that have ideas that can be tested should be
Mm.
the ones that are rewarded, and people that talk about things that will not be tested in the next millennium, should be at the fringes of physics, because
Right.
if we cannot test those ideas, we can never make progress. In fact,
Mm.
there is a whole culture right now that says experimental testing is not even needed, and moreover, you will never be able, even in principle, to prove my theory wrong because it's so flexible. So any experimental result that you will get, I can accommodate by adjusting the parameters of the theory. So I say, what kind of a science is that, where
Yeah.
any experimental evidence can be? I mean, a theory of everything is a theory of nothing.